look at a method used to balance redox equations, and specifically these are going to be the net ionic equations. In this first example, we're looking at is the reduction of Fe3 plus to Fe2 plus by tin 2 ions. So we're first going to start by writing the unbalanced equation in ionic form. So Fe3 plus Sn2 plus is going to Fe2 plus Sn4 plus. The next thing that we need to do is separate the equation into two half reactions. So the Fe3 plus is going to be going to Fe2 plus, while the tin 2 plus is converting to Sn4 plus. In this case, our oxidation reaction is our reaction involving the tin ions, and our reduction reaction is the reaction involving the iron ions. That's based on the fact that in an oxidation reaction, there's a loss of electrons, and in a reduction reaction, there's a gain of electrons. Now, at first glance, this reaction looks like it might have been balanced, but if we look a little bit more closely, we can see that the charges are not balanced. So while the atoms are balanced, we need to make sure that the electrons that are transferred during this chemical equation or chemical reaction are equal. So on the left-hand side, we can see that the charge is 5 plus, while on the right-hand side, it's 6 plus. So that's showing us that with this 1-to-1 ratio, there's some kind of an imbalance in the electrons being transferred. So how we handle this is by adding electrons to one side of each half reactions to balance the charges. So for our tin reaction, we need 2 electrons on the right-hand side. And with our iron reaction, we need 1 electron on the left-hand side. So this is where we can see the electron imbalance. Our next step is to equalize the number of electrons in the two half reactions by multiplying the half reactions by the appropriate coefficients. So this second reaction here, the iron reaction, is going to need to be multiplied by 2 in order to fulfill this step, where we want to equalize the number of electrons. So you can see that we doubled the entire reaction of the iron. Now our final step is to add the two half reactions together. So we've got our oxidation half reaction and our reduction half reaction. We're going to add those together, and the electrons are the same on both sides. And so those are going to cancel, and we are left with tin 2 plus 2 iron 3 plus goes to 2 Fe2 plus tin 4 plus. And our last step here is to verify that the number of atoms and the charges are balanced, which in this case they are. We can see that we've got 2 iron atoms, we've got 1 tin atom on either side, and then for the charges on the left-hand side, we have a total of 8. So we have 2 times 3 plus an additional 2 for a total of 8. And on the right-hand side, we have 8 as well. We've got 2 times 2 plus, which is 4, plus our 4. Okay, so we've accomplished balancing a redox reaction.